So I think it's important to talk about what works and like things that might need some attention. So just to be clear what I'm talking about, there's two things that sometimes get confused. There's the XCM message passing protocol, and there's the XCM like the messaging interpretation itself. So I'm only going to be talking about the higher level of using XCM. So I'm not concerned with the passing of the messages in this talk. So I will start by talking about the basics, how pretty much all of the chains have been using XCM so far. Then I will go on with some applications that go a little bit further, that still works very good in the current XCM. Then I will have a look at ways we can customize the processing of XCM messages to fit our needs. And finally, I will talk about some things that are a bit painful in the current version of XCM and how it might improve in the future. Wait, where are we? Yes. So let's start with the basic token transfers. This is, I would say, what 95% of all the messages probably are on Polkadot. So what the typical situation is that each chain is the reserve of their own tokens. So for example, the Interlay chain is the reserve of our native Inter token, is the governance token, and of wrapped Bitcoin. So what happens is if you send these tokens to other chains, then it always goes to the reserve first. So for example, if you send from chain A to B, like you see in the image that I copied from Gavin's blog post, then it always goes first to the reserve so that the reserve can update the bookkeeping to make sure that parachain A isn't able to mint any arbitrary amount of tokens. And then the reserve passes it along to the destination. And actually, this case is not super common. The most common situation is when the reserve is either, like when the token that you are sending is either the reserve or when you are sending to the reserve. So in this case, then there would be no chain B, and it's just directly from like between two chains. More recently, we also have state mine and state mint, which is the reserve of tokens such as USDT. But the principle remains the same, that you send message to the reserve, and if needed, it sends it along. So if your chain has been doing token transfers, then you also have been doing like the setup of the channels, because this you need to do this before you can send any tokens. So how this is typically done is by sending a message to the relay chain using containing a instruct, a transact instruction that instructs the relay chain to either request an opening or to accept an opening of a channel. So like this is pretty familiar, I think, to everyone that has been using parachains. And this also is really what is working quite well in the current setup. So I'm very happy to have this work as good as it is. What else can we do with the current version of XCM without any kind of customization? There are two main things that we have had a look at to see like two other applications that are interesting to us. So the first scenario is that we have tokens on Interlay, but we are mainly, or at least we're mainly a bridge. So you get your tokens on our chain, but you couldn't really use it on our chain, like to actually use wrapped Bitcoin. You needed to send it to other chains. And like one of the main use cases is on dexes or in maybe also in lending. But we were looking into dexes in trading pools. So we wanted to incentivize these trading pools because we want them to be used. So there are two ways we can provide these incentives. we can send the required tokens to the destination chain, and then have some trusted account call the required function to actually make them available as incentives. But of course, you have this problem, like, who will be the trusted account? Like, do we trust some account like of the external parachain that we send it to? Do we send it to an account that we control? It's problematic to have this middleman that you have to rely on. So the alternative is to do it directly. So to have a single XCM message that first sends the tokens and then has a transact to directly call the necessary function to deposit the tokens into the pool to be used as incentives. And a little bit more advanced case of this is if you don't want to provide incentives, but if you want to instead provide liquidity into a pool. So the idea is the same. You either need to trust an account or you use transact. The reason why this is a little bit different is because you get, when you deposit liquidity, you get LP tokens, which at some later point you will want to do something with. So you will need some account to do something for you at a later point. And yeah, so the ideal way to do this is with transact, so that the governance system is fully has full control over what is happening with these tokens. So, like, for example, we could put liquidity into a pool on Akala, and then half a year later, our governance might decide, okay, now we want to cash these tokens out or like to exchange them. Then we can send a new message, and it will be executed from our from the account that's representing our sovereign, or like from the sovereign account that is representing our chain. So to generalize a little bit, what you can do is, as governance, you can send your tokens somewhere for some purpose. So you can put them as liquidity. You can swap them. You can invest them. Maybe you can use them in a lending protocol. Like maybe you want some stable coins. You could even, like, other parachains could even run a vault technically on Interlay, like from their governance. I'm not saying it's super practical, but in theory it's possible. So anything that you can do on behalf of a governance is generally working well. It's only when you want to do something on behalf of a user that it gets complicated, but I will get back to that later. So now we will have a look at how we can customize XCM to do what we want. Because XCM was developed with certain expectations, and if you're if what you want doesn't exactly meet it, it can be difficult. So the case that I want to talk about mostly is about taxing. I'm aware that this has a bit of a negative connotation, but anyway, so what I mean with taxing is that typically when you are sending an XCM message to another chain, then you are paying some fees for the execution, right? Like the fee will be dependent on the complexity of the message. So typically the more instructions are in a message, the higher your fee will be. But we are looking into if it's possible to pay a fee that is not dependent on the complexity, but rather on the amount that is being sent. So to take a fixed percentage of what is being sent. And the reason why we were looking into this is because a lot of revenue in DeFi is being generated on trading pools, on lending protocols, but as a bridge that is just providing red Bitcoin, there are more limited ways to like there's not as many ways to earn revenue, and we need revenue on our chain to be able to incentivize vaults from participating in our protocol. So this is why we were looking into this application. Another application that we wanted to look into is if it's possible to limit XCM just as a kind of safeguard. So if we see some huge amount being received or being sent, then we might want to take some action, maybe reject it, maybe put it into a queue for approval, whatever. Like at this point, we were mostly concerned with whether or not we could, rather than whether or not we should, and like what should exactly happen in these cases. In the end, everything will of course be up to governance to approve. So to look, this is not working great. Okay. So I want to explore how we can implement this taxing, because XCM doesn't really support this very well. Like I said, it's really only meant to pay fees for execution, and like that's it. So one of the ways that we can customize it is by changing the barrier. The barrier is this very simple function that determines whether or not a certain message should be executed. So the standard implementation will make sure that the message contains a by execution instruction to make sure that an attempt to pay fees is made as soon as possible. So the potential that we have here for implementing taxing is to reject any messages that don't have sufficient fees, like that aren't transferring sufficient fees. The problem with this is if we have a very restrictive barrier, we put a burden on the sending chain. So any chain that would send tokens to Interlay would need to account for this. And this is a lot to ask. Like it would be in the way of interoperability. So the next way that we can customize is using the weighter, which, given a message, is returning the weight. So the idea here is to inspect the message and to make the weight scale with the amount being sent. The problem there is that typically only a single asset is being used to pay for fees. You might be sending like only a couple of cents worth of the asset that you use for fees, and like a ton of like $1,000 worth of another asset, and yeah, then it would this approach would fail. The next way you can customize it is by customizing a trader, which, given a weight, returns or really takes a certain amount of fees. So if we can like make this fee dynamic, then we would achieve kind of what we want. The problem is that again, like only a single asset is being used in for paying for execution, and as you can see in the refund, only a single asset is being returned also. So it's really not well supported to like take the tokens that we want. So the next way is not really a way to customize it. It's more, I would say, it's glue logic that you need to implement to have the XCM code interface with your parachain. So it's these two functions, deposit asset and withdraw asset, that are called by the executor whenever a XCM message is doing some kind of transfer to or from an account on your parachain. So the idea would be like just hook into these functions, and like when there's a withdraw, just reduce the amount that you're withdrawing and like transfer something to Treasury or DAO. The problem here is that this would totally mess up the bookkeeping. The receiving parachain would have different view of what it has access to compared to what it actually has. So this is also not suitable. So the way that we finally managed to implement taxing is by actually using the execute XCM hook, which is really the highest level like entry point into the XCM executor. So any palette that is using XCM is calling this function execute XCM. So the idea is that if we can use our custom version of this that inspects the message, then transforms it, and then passes it on to the standard executor, then we kind of achieve what we want. So this is what that would look like. So we have this function execute XCM. We determine if it's outbound or inbound, and we apply a transformation. And we just call the original standard executor with the transformed message. So how this transformation would look like is like this. So in our case, when we are sending messages, sending tokens from our chain, we have two different cases. Either you are sending tokens that are native to our chain or not. So if they are native, then we have this instruction, the transfer reserve asset. So what we would do is we would reduce the amount inside the transfer reserve and then add the transfer asset, which would actually transfer some amount to the treasury or to DAO. The other case, when you are sending tokens that are not native to the chain, it would look like the withdraw asset and a initiate reserve withdraw. And the idea would be the same. You modify the withdraw, reduce the amount, add the transfer asset to treasury or to DAO, and execute as normal. And of course, we could just modify our palette that we use for sending tokens in the first place. Like we could just fork X tokens and like do it directly there. But this is kind of a non-intrusive way, so that's the advantage of this approach. And of course, we don't have control over what is coming in, so we need to have this anyway. So when you are receiving tokens from other chains, the default barrier makes sure that the first instruction is something that puts some tokens into the holding. Then there's any number of clear origin instructions followed by execution. So what we do is we just insert this deposit asset instruction, which transfers to DAO, and then we continue with the message as normal. And the question is, does this work? And the answer is yes, mostly. So the most common case will continue to work. So what is typically being done is token transfers typically first put something into the holding and then transfer everything that is in the holding to some account. So that will continue to work as normal. But it is also possible to create messages that don't take everything from the holding, but rather take a specific amount from the holding. And if the amount in the holding is not as you expect, then that will fail, which can cause problems. And the same is true is when you have a transact that is expecting a certain balance to be in some account, then that could fail. So that is the price that you would have to pay to implement this taxing. So conclusion here is like, is it possible to implement a fee that is dependent on like the amount being sent rather than on the complexity? Yes, but it's kind of ugly, but it is possible. All right, so let's move on to the final part, which is the pain points. And there are some things that aren't really working super nice with XCM, and some of them are like not something we can do about, but I still want to talk about them. So my first pain point is weights and fees. So weights can change at any time. So for example, when there's a upgrade of Polkadot, like the relay chain, then weights are changing, and this can cause messages to fail unexpectedly. And yeah, for me anyway, the idea of weights is a little bit weird, because as a user, you don't really care about weight. Like you You don't care how long it takes to execute on some chain. What you really care about is how many fees will be taken. So yeah, that's my gripe with fees on XCM. But you can put a limit on the amount of fees being taken, and that helps at least. So there's the case when you are sending a very small amount to some account, then you need to make sure that the amount that is being received is above the existential deposit. Because if it's not, then it's essentially lost. And you can't really determine that if you don't know how many fees you will have to pay. So that is problematic. And even if you put an upper bound on the fees, then you can know that, okay, at least I will receive this amount, which will be above the existential deposit. Like, if it fails, then like these tokens are kind of in limbo. Like, it's really annoying to get them out again. So what happens is, if a message fails, then you need to reclaim them later, and hope that at that point you are able to use these tokens to pay for execution. In the case of the existential deposit, like, you might never be able to get them out. The next pain point is atomicity, and this is something that yeah, I don't think we can do anything about, but it's a bit annoying because XCM is essentially asynchronous, which means that you are doing your extrinsic, which will initiate the transfer of a message, but you don't know what happened to it. Like, you don't know the result. And like, the ideal situation would be that you can that it would be atomic. That if your transfer fails on the receiving chain, that you can abort like the original extrinsic. That would be ideal, but yeah, this is probably not feasible to ever implement. But yeah, it's a pain point to have to deal with. The next one is testing. Testing is painful. So if you're doing token transfers, then it's okay. Like, the only thing you need to be sure about is the weights. But if you're doing anything more advanced, then you want to be sure that it will succeed before you actually transfer the tokens. Because, for example, in the example that I gave earlier about depositing tokens into an AMM as incentives on behalf of the government, it can be a lot of money that you're sending. So like, you don't want the message to fail. So my ideal solution would be a way to dry run messages. So like, this is something that we already have for extrinsics. You can also, like, there is already an RPC that you can use to see, would this message or would this extrinsic succeed or not? And you get back like, okay or failure. If you can get the same for XCM messages, like saying that if this message is being received from this origin, would it succeed or would it fail? That would already be a big help. But if I'm dreaming, then I'm going to dream big. So what I would really like to see is a way to see the side effects of what you are dry running, or like of any extrinsic in general. So if you could see that this extrinsic or this XCM message, if executed, would change this storage item to this value, would fire this and this event, that you can see exactly what happens, that would be really, really amazing. I don't know if this is feasible to implement, but it would be super, super useful. All right, my last pain point is the lack of signing or the lack of trust between parachains. So the examples that I gave earlier about things that work good, they are sending messages on behalf of governance. So on the receiving chain, they are sent the origin will be the sovereign account of the sending chain. But if you want to do something on behalf of a specific user, then yeah, it's not really possible, because how do you know that this user on the sending chain gave permission to send this extrinsic? You don't. So there's two theoretical ways to deal with this, or maybe three. So the first would be to send along some kind of proof, but I think in practice this is not really feasible. But the alternative that I think is worth considering, like as parachains, is to have some kind of explicit trust that you are in control of as a user. So one way this could work is to use something like the proxy palette. So if you can, as a user, authorize some accounts to make a certain subset of extrinsics for you, then we can do a lot more. So if Alice on Akala, for example, can say, okay, I will allow Interlay to make this specific function for me, then this would open up a whole new set of possibilities of uses of the transact instruction. So this is something that I think we could consider. I also talked with some people from Moonbeam earlier. I heard that they're also working on deriving accounts, so that you are able to execute on behalf of a user, but not like of the original account on the receiving chain, but of a derived account. Like the account would be basically, for example, Interlay/Alice. So that would be like for me a partial solution. Yeah, so I really should have added another slide here because it's adding on not the best note. So just to summarize, like there are some pain points, but like the main thing that XCM is being used for, token transfers, this is working really quite well. And yeah, with enough effort, it is possible to customize it for things that it wasn't really intended for. Yeah, so overall, I'm very happy with XCM, and I hope that XCM v3 is bringing some improvements to some of these points. Definitely not all of them, and for example, this last one cannot be addressed by XCM itself. It's like something that needs to happen on a layer above it. But I hope that in the future the situation will improve even further, and that we can continue to use it and to have more and more use cases. All right, thank you for your attention. Are there any questions?
Yeah, I maybe didn't quite get who you would be proxying to in this last example. You said proxy to Interlay, but that doesn't...
So if you execute, if you send a message from Interlay to, for example, Akala, then when you are interpreting this message, the origin is set to the sovereign account of Interlay. Like it's a derived account. So what you would do is you would authorize the Interlay sovereign account to make calls on behalf of you. So then if you do a transact, then this is executed with Interlay sovereign account, and this would then be authorized to make calls on behalf of this user.
Right, okay, so on the remote chain, you would be able to authorize for, any arbitrary extrinsic that it would be, the sovereign account would be then signing as you.
Yeah, so a specific user on Akala could say, okay, I trust Interlay to make DEX exchanges for me. Like Interlay sovereign account is allowed to do exchanges of tokens on behalf of me. Like that would be an example. So why is this interesting? Because it would be amazing if we can can automate the whole chain. Like if we have so on our chain we have vaults running, which are depositing collateral and they are earning some rewards. And ideally, you want to convert the rewards that you get back into collateral so that you can like compound on your gainings. So if you can send a message to Akala, which has a DEX, and do the transfer there, do the exchange there, and then to send it back to be deposited as collateral into the original vault, like that would be super convenient.
It feels, yeah. I was just going to launch into a discussion there. Maybe it's best not to do that.
I mean, yeah, that's fair. I'm not saying it's definitely the best way. I'm saying that it's like a way around that or like one of the few ways that we can get around of the lack of signing, because it is a problem. Like it is really holding back a lot of applications. And I'm not saying it's the best solution. It's a possible solution that might be worth considering, but I'm also very happy to hear other ideas.
Why can you not send a signature within an XCM message?
How would you get the signature? Like, how would you generate it? Like, you would need to sign something.
Sign offline and
but like
send it as data.
Like either you would like if the message is coming from the Interlay chain, like the Interlay chain can't know your secret key, right? Because like it will be public knowledge at that point. So you would have the user sign something before you even make the call on Interlay. And at that point you might just, just make the call directly. Like just make the call on Akala if you're already signing the message. If you know like exactly already what needs to happen in advance. All right, any other questions?
Is it possible to schedule XCM calls?
Schedule in what way?
Like for example, if X happens, send Y message.
I mean, on your own chain you can have any kind of logic, right? Like you can have a scheduler ballot that is scheduling something for the future, and you can implement any logic that you want in your own ballot. So, like in your ballot, you can do whatever logic you want. Like if you're talking about inside the message itself, then that's not currently possible. But something like this will be possible in XCM v3.
Okay, yeah, I was imagining a use case where one of the first applications that you mentioned about being able to LP from the treasury. Mm-hmm. So the LPing is done in a foreign chain, right? Coming from the origin chain, which is the treasury, right?
Yeah.
But if you could somehow say if X happened in Akala DEX, then send the message to LP in the...
Right. Yeah, this would require logic to be on Akala, for example, yeah. Like on the receiving chain.
Okay.
Or I guess you could implement. Yeah, like if you want to keep it on chain, then I think that's the only option right now.
Thank you.
Cool. Anyone else? All right. So thank you very much for your attention.